Well, hello everyone. In this video, I would like to go over homework question number 17. I'm also going to do a couple of videos today about some of the other homework problems about mirrors, but we'll start with this one, number 17. So the question is, how far away in meters is our nearest star, Alpha Centauri, if it takes light 4.3 years to reach the Earth after leaving this star? Okay, so let's draw a quick image. Drawing pad upside down, there we go. So we have Alpha Centauri and Earth. Okay, now the distance between these two is what we're trying to figure out. How far is this distance? And we'll go back to our kinematic equations, delta x, our distance here. So VI, VF, AT, and delta x. Delta x we don't know, but we do know the time. The time is 4.3 years. But that doesn't do us a lot of good, remember, because we want our time in seconds. So I'm going to have to convert that. So 4.3 years. I'm going to use that train track method. So 1 year is 365.25 days. Now, if I was just doing this for like a year or less than a whole year, I wouldn't necessarily have to worry about the 0.25, but 4 years, that includes that whole leap year where we get an extra day. So I'm going to add that in. And then 1 day, we'll round that to 24 hours. And then 1 hour is 60 minutes. And then 1 minute is 60 seconds. So if I crunch all those numbers in my calculator here, I do 4.3 times 365.25 times 24 times 60 times 60, and I get this monstrosity out of my calculator. 1, 3, 5, 6, 9, 7, 6, 8, 0. And so if I'm going to go with 3 sig figs, my time is going to be 136000000. Or I can write that in scientific notation, 1.36 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the next thing I need to figure out is the velocity. Alright, so I'm dealing with light here. Okay, so how long does it take for light? Well, I need to know the speed of light. The speed of light, c, that constant in a vacuum, so the distance here between Alpha Centauri and Earth is going to be a vacuum. So that c is 3 times 10 to the 8th meters per second. So our light is going to start at 3 times 10 to the 8th meters per second. It will finish at 3 times 10 to the 8th meters per second, which means it will not have an acceleration. 0 meters per second squared. And now I'm trying to solve for delta x. So if I go back to those equations, let's pick a new color here. We have 2 delta x equals vi plus vf divided by 2 times t, or delta x equals vit plus 1/2 at squared. Either works. Either way you get the same answer. I'm going to go with this one over here for the example because I can just send that to 0 because there's no acceleration. So delta x is going to equal velocity, 3 times 10 to the 8th meters per second, times the time, 1.36 4.36 times 10 to the 8th seconds. So we get a distance in meters now, because we're using meters per second and seconds. 3 times 10 to the 8th times 1.36 times 10 to the 8th and I end up with 4.08 times 10 to the 16th meters. Okay, so that's part A. How far is it in meters? Well, the next thing it wants me to do is in miles. So we'll switch over to red here. So how about in miles? Well, all I need to do, since I already have the answer here in meters, I just need to convert that into miles. So I'll do that in this section over here. So 4.08 times 10 to the 16th meters. And there are 1,608 meters in 1 mile. And the reason I know this, track and field, 4 laps around the 400-meter track is the mile race, a little short. But even if you rounded this to 1,600 meters in a mile, you're going to get the same ballpark answer because we're dealing with such an astronomically huge distance. So here, I do 4.08 times 10 to the 16th times 1, and then divide that by 1,608 meters, and I get 2.54 times 10 to the 13th miles. Okay, now for the last one. This one's actually a lot easier than it might seem. In light years. By definition, a light year is the distance light travels in a year. Well, if it takes 4.3 years for light traveling at the speed of light to get from Alpha Centauri to Earth, the distance in light years is going to be 4.3 light years. And that's a lowercase l there for light years, not a 1. Okay, so our 3 answers here are 4.08 times 10 to the 16th meters, 2.54 times 10 to the 13th miles, and 4.3 light years. So hopefully that helps with number 17. In the next video, I'm going to do questions 19 and 20.